Um, Hi, welcome back to the continuing lecture in investment analysis. This is Dr. Jeff Hong, and this is like seventh video in the bond price and bond yield. Um, so there's a we were talking about yield to maturity last time in the last video. And I've given you um, several, definition of yield to maturity. Uh, also, several ways to uh, interpret the yield to maturity. Um, there's still another way of looking at yield to maturity. Um, let's suppose, let's take a look at this. Suppose, also realized compound return. Realized compound return. What is realized compound return? That's exactly, the geometric average. And what is the geometric average? Geometric average is the annualized growth rate. Annualized growth rate. And now, if you and in Finance 100, this was probably, this was, in my class at least, the first concept that came up in the first topic, return on investment. Now, basically, geometric average is, also called, compounded growth rate. Uh, and sometimes they call it, okay, CAGR. Compounded annual growth rate. Okay, but I don't like, I don't like this expression because it doesn't have to be annual. I mean, if you're dealing with if you're dealing with annual growth rate, yeah, it's annual. But what if it is quarterly? What if it is monthly? Then we will have to change this A to CQAR, right? Compounded quarterly growth rate, or monthly CMGR. So in other words, this A is not a fixed term, right? Uh, it can be any compounding frequency. But at least CGR is a correct expression, compounded growth rate. So so what does and it is basically how we find uh, the growth rate or annualized return, annualized growth rate. And I said, the difference rate difference between growth rate and return. There is certainly a difference in growth rate and return. And to explain that, I think I will have to. Let's see if I can also. Oops, what's going on? Yeah, let's see. Instead of just explaining in words, let me borrow something from old Finance 100. So let me give me Okay. Our first topic in Finance 100 was so in Finance 100, I used the first example I used was house value, right? Uh, as an example, geometric average, I used house value, example of house value, and at the time I used two scenarios. One scenario, suppose oh, I can't use one scenario. Scenario one was that you buy the house and use it as your uh, home, right? So it's a residential property. Second scenario two is you buy the house as an investment property. So basically you rent it out. Now, in under these two different scenarios, there will be two different cash flows. One, if you bought the house only as as your home, there won't be any additional cash flow. But the only cash flow that comes from this house is the cash flow from uh, the growth in the house value, right? Suppose you bought the house in 2005 and in 2000 and for $150,000, and in 2006 house value increased like this. And if you sold the house, then the cash flow coming from the capital gains is like this, 30K, and so on. Every year you would have cash flow from capital gains. Of course, unless you sell the house, it's just paper gains, right? Uh, you can understand this, unless you sell the house, it's only paper gains. There's no actual uh, realized, gain. But even on paper, right, you have capital gains. Now, if you bought the house and used it as a rental property, you rent it out and you have rental income. And in my example, the rental started out in 2008. So between 2008 and 2009, there was rental income of, right? In other words, you bought it at the end of year 2005, so there was no rental income. Between year one and year two, no rental income between year two and three, no rental income between year two and four. Okay. Uh, I mean, then from 2008, you rent it out. So there's rental income. So in other words, each year, right, there's cash flow from capital gains and cash flow from the incidental income, right, or income from rental income, right, cash flow rental income. Now, if you in scenario one, because there is no rental income in scenario one, the only source of income is capital gains. And if you calculate the growth rate in your house value, right, you have only growth rate, right? And in that case, return from these are year by year returns. So these are annual returns. So it's not, and I explained there's a difference between annualized return and annual return, because annual return is used interchangeably um, as year to year return. But if you think about it, if you take the average of this, that's annualized return, and each individual year by year return, that's, you can say, year by year return or annual return, right? and they cannot be the same. I mean, that's all uneven, it goes without saying. But if you take the average of that, that's annualized return. And the average we're talking about here is not simple average, it's geometric average, right? Now, but in scenario two, since there are two cash flows from this investment, so if you include also the not only the capital gains, but also the rental income, then, and if you take the return for each year, of course, for the first 3 years, you can say for the first 3 years there's no difference because there's no rental income. But from year 4, you see clearly, there's a difference between just the growth rate and a return. And if you take the average of, geometric average of this, that's called yield. Okay. But anyway, so that's the difference between growth rate and yield. I'm going to stop sharing this and go back to so then compounded growth rate or realized compound return is basically geometric average, right? And then so this is the scenario 1 in the house value example. No, it can be scenario 1 as well as scenario 2 in this case. Why? What this means is realized compound return means if assuming that what's the return on the bond if all your coupons are reinvested back into that same bond until maturity. Now think about it. What do you do with the interest? What do you do with interest if you have, when you receive the interest from the bond? Of course, you have two options. You can take out that interest, right, from your, trading account, bond, or stock trading account, right? You can withdraw it and use it. Or you can use it. The interest is paid, and you can use that interest to buy stocks or something else, right? But if you don't say anything, if you don't take any action, what will happen? That interest, right? That coupon payment that was paid is in that bond account that and then usually, when you invest in something, with your broker, I mean, you buy it through your broker, so you have a brokerage account, and usually, the unwritten rule is if you don't specify anything about the bond interest, it gets reinvested in the bond. Or it depends on the routine practice and the policy of that brokerage firm. Usually there is an account, short-term money market account, they put the dividend or interest into. But if you sign reinvestment, dividend or interest reinvestment plan, sign a contract for that, then the dividend, the interest is reinvested into the bond, and in case of dividend, it gets reinvested, in the same stock. So then think about it. If all the interest is being reinvested, all the coupon payments are being reinvested in the same bond all over again, then it becomes exactly um, compounded growth rate, right? So so it looks like this. This is, what they call horizon analysis. Horizon analysis is analysis of bond returns over a multi-year horizon, because it's just more than 1 year. So first, suppose you uh, have one bond, just a single bond, and coupon rate is 10%. If coupon rate is 10%, 1 year later you will have $100. Okay, and then if you reinvest it into the same bond, it will earn 10%. So 1 year later, which means at the end of year two, you have $110. That means that $100 coupon will become $110. This is a very basic concept of compounding. And the original 1,000 will, at the end of year two, um, the original principal will have, this is, the principal as of the end of the principal is 1,000, but as of the end of year two, you'll have 1,100, which was the value of the principal at the beginning of uh, year two, right? This is end of year one as well as beginning of year two. Yeah, you may so think about it. At this point, that's the end of year one, right? As well as beginning of year two. This is, beginning of end of year two as well as beginning of year three. Now, you might wonder, oh, doesn't that 1,100 then earn again, 10% interest? Well, that interest portion is taken care of here, right? So that's why eventually, this is basically compounding. You have, that's why you have 1,210 at the end of year two, if it was reinvested. But what if the reinvestment rate is not 10% anymore, but 8%, right? Yeah, this brings us back to the question of can we know the realized compound rate ex ante? In other words, a priori? No, we cannot. We don't know it with accuracy due to margin of error in reinvestment rate forecast. So that's why there is reinvestment rate risk. Remember, reinvestment rate risk is the uncertainty surrounding cumulative future value of reinvested coupon payments. Now, if you reinvest it into the same bond, aren't you supposed to get the same coupon rate? No, there's no guarantee for that. Why? If this bond, when you first bought this bond, the coupon rate is 10%, but that's when you bought it. That's when you bought it. In other words, the bond that was issued, let's say in 2015 with 10-year maturity, and then if you bought it at the time, right? And if you then this same company will, this issue of bond will until it is 10 years, it will pay 10% a year, right? But can you, to get 10%, you have to buy this issue that was issued in January of 2015. I mean, in the secondary market, these bonds will be traded, right? Some people may, who originally bought it in 2015, January of 2015, some of them, the original buyers, may have sold it in the market. And then you can, if you're lucky, you can buy it again at that price. At the market price, but it will pay you 10% coupon a year. Think about it. How many people would have sold? I mean, some people may have sold, but most of them would be holding on to it, and including you would be holding on to it. Then, what are the chances of buying this same issue of bond, right? 2015 January issue, January 2015 issue. And if you cannot buy the same, and then the next issue, let's suppose, this company issued new bonds in 2016, August of 2016. And by then, the market interest rate would have moved, right? The interest rate would have moved. So then they may not be paying, if the interest rate has gone up, then you would have, it would be wonderful if interest went up, then, if interest rate is 12%, then, and in August of 2016, if you reinvest your coupon payments into the same company's bond, now you can lock into 12% interest, right? But what if the interest rate has fallen in the meantime? Then your money has to be reinvested at a lower interest rate, and you can tell what it's going to be, right, ahead of time. Now, so what if the reinvestment rate, so the interest rate has gone down, what if reinvestment rate is 8%? Then your principal of, this is not principal anyway, because, it's par value, right? But anyway, there will be 1,000, but, although we are talking about the bond, we're just, simply going back to the, single cash flow future value model. And then if the principal was 1,000, at the end of year 2, right, your principal will be 1,100, right? And the first interest of 100 that you receive will grow to $108 because now the interest rate has changed. It has fallen to 8%. So then your future value at the end of year 2, right? The future value at the end of year 2 will be, in this case, $1,208. So in other words, this is the problem of reinvestment rate, or the risk, reinvestment rate risk. Okay, but again, this is the same as single cash flow future value model, right? Single cash flow future value model. right? Because in single cash flow model, you put $1,000 in the bank, and the bank pays you, a fixed 10% interest. Think about the CDs. CDs pay you fixed, and if you put it, for n number of years, it will continue to pay you 10%, until maturity. Now, this is what is meant by yield also, right? In other words, yield is the real same thing as realized compound return yield is just the same thing as realized compound return under the assumption that all the interest is reinvested until maturity in the same bond at the same coupon rate, right? Which is internal rate of return. Okay. But then it's only an estimation because we know, because of the reinvestment rate risk, we don't know if it's going to be really reinvested at the same coupon rate. That's the reinvestment rate risk. So I want to bring you back to remember. Okay, so remember there are four types of there are four types of risks in the bond, right? The first risk is the default risk, of course. In any lending situation, right? Because you're lending, the greatest concern is the default risk, right? Second risk is the liquidity risk. And if you remember, Finance 100, you should, especially if you took it with me, liquidity risk is what? The risk associated with unknown issuer of the bond, because if the issuer is not well known, its marketability goes down. In other words, you cannot easily liquidate it. And 1 and 2 and 3, third risk is the maturity risk. Maturity risk is also called interest rate risk. It goes by many names. And why maturity rate? It's hard to write. Because the longer the maturity, right, there's a lot of more uncertainty about the interest rate changes, right? Because if interest rate changes suddenly and unexpectedly, right, maturity risk is also called, price risk. Think about it. The price of your bond holding drastically changes. For example, and it's usually, downside. In other words, if it goes up drastically, if interest rate goes down drastically, you probably don't have that much, complaint, because the valuation, because it's always present value, the valuation of your bond holding goes up. But if it changes, significantly, right, and just abruptly without, then the valuation just drops like crazy. That's why it's also called price risk. The longer the maturity, the higher the chances of interest rate fluctuation or interest rate change, and which affects the price. That's called price risk. And it's also called uh, interest rate risk because it comes from the changes in interest rate. And it can be also, it can hit you in two ways. It can hit you in valuation because, I just explained, and then reinvestment rate risk. What if the reinvestment rate goes down? Think about it. Especially if your bond was paying already very small interest, like 1% a year. So that's like for $1,000, you just get $10 a year, and then this $10 will be reinvested even at much lower rate if it goes down, right? So, and then the fourth one is the inflation risk. Inflation risk. I'm not going to write inflation risk. And think about it. Default first one and the second one are borrower specific, right? The company specific, in other words, the bond specific. But the third one and the fourth one uh, they are not company specific. It hits every company across the board, every bond issuer across the board. I mean, every bondholder across the board, right? So this is maturity risk and inflation risk. In other words, interest rate risk and inflation risk are inherent in the coming from the macroeconomic system, and it's inherent in the bonds, every across uh, every bond, right? Whereas 1 and 2, default risk and liquidity risk, are specific to individual bond. Okay. All righty. So the time's up. I'll have to cut the video here, and I'll see you in the next video. Thanks for watching.